Great. So, by way of introduction, Lee had asked me to introduce myself, and want to go ahead and do that. So, I am Sean Colleen. I'm from the Philadelphia area originally, but I've been in the Arlington area for probably 10 or 15 years now. Very happy to be here at caparea.net. I've spoken here before. As Lee mentioned, I'm a Microsoft MVP for a few years now. Really hoping that I can get the award and actually make it to an in-person MVP summit, which has not happened yet. I received my award right going into COVID times, so hopefully getting back to that soon. But I am currently Principal Technical Fellow at Accela for Modern Software Delivery, and so been at Accela for a bit now. Got about 6 years of experience there. Very happy to be in that role. I currently set strategy for the organization around modern software delivery, and I serve as sort of a technical advisor to various accounts, and I still get to get my hands dirty with some code, which is always fun for me. So that's already too much about me. The one thing I will say is we'll pull up the obligatory test of my screen share. We should be able to see. All right, so this is the one and only slide in my presentation. So if you want to find me on Twitter, you can find me at SJ Colleen, and GitHub, I'm Sean Colleen, and all of my contact information is on my blog at seancolleen.com. So happy to meet you, happy to sync up with you, always happy to continue these conversations before or after any time after the talk. So tonight, we're going to be doing something a little different, and it's something that I may come to regret. We'll see. I have done very little preparation for this talk on purpose, which is not my typical fashion. So what we want to do tonight is a little bit of TDD Your Own Adventure, the title of the talk. What we want to do is talk about the questions that you might have about automated testing or test-driven development. Now, we've seeded that with a few questions that have come in through Google Forms, but I kind of want to kick it off with a little bit of a poll here. So I'm going to go ahead and share my screen once more here, and I'm going to throw up a poll on the screen just to kind of seed our activity tonight. I'm going to present that in one moment here. All right, so what I'm going to ask you to do is I'm going to ask you to visit a URL, and that URL is going to be at the top of your screen here. It's pollev.com/SeanK431. I've got a couple of snap polls there for you just to kind of understand where we are in terms of which testing libraries and tools you might be familiar with. Now, again, obviously, these are only 4, and one is kind of a group of several, right? So this is not a scientific poll by any means, but just to kind of seed some of our discussion tonight as we look into some of these items. I'm curious as to what testing libraries and tools you're familiar with. And I know these are not the full spectrum. So we'll give a couple seconds for this snap poll just to kind of help me understand where we are. And I'll switch to I've got 2 more questions for you as we kick off the event. All right, so unsurprisingly, we do have a decent amount of folks who are familiar with mocking libraries. NUnit and XUnit are tied. That's no surprise. Less folks are familiar with Spec Flow, which is pretty interesting to me because that's been a phenomenal tool in my toolbox. So maybe we'll talk a little bit about that tonight. I'm making a note of that for myself. Okay, it looks like NUnit has slightly pulled ahead of XUnit there, which is lovely. I have an experience with XUnit or with NUnit in that I am currently the lead of the NUnit documentation project. However, I also really love XUnit, and I sometimes, I would say I often personally prefer to start with XUnit. Great, okay, thank you. So that's really helpful. First bit of polling there. I'm going to go ahead and go to my next poll just to kind of understand which tests and which types of tests have you written in .NET. So unit tests, integration tests, acceptance tests, and I'm purposefully not going to explain what those terms are, so you can go based on what they mean to you. Give it one more moment. Okay, a lot of folks writing unit tests. Okay, so less folks writing acceptance tests and UI tests, it looks like, which is probably a little bit correlated with that lack of familiarity with Spec Flow. So hopefully we may be able to feed two birds with one stone, I guess is the expression these days, and maybe introduce both of those. Looks like we have less folks doing benchmark tests in general, and Gherkin-based tests are getting less of a response as well. Okay, that's very helpful. And lastly, I'll give it a little more time on this. This is a poll that you can answer and upvote as well. What are your biggest challenges with automated testing in .NET? And remember, so you can add a response, and you can also upvote other responses that are there. And all of the presentation piece of the talk today. After that, we're going to kind of open up the floor for questions, and at the same time we're going to talk through some of these tools and libraries. And at any point, if you want to steer the discussion in a different place, into a different place, feel free to do so. We're going to be highly improvisational. We're going to try to adapt. Maybe it'll work, maybe it won't. I'll ask your feedback afterwards. Okay. I see making my code testable has got an upvote there. Okay. Adding scenarios that depend on data. Okay. Okay, this is really helpful. Thank you. Give it one more minute here. On-demand integration environments to run web tests. Okay. How to structure test projects. Dependency management. Okay. Great. All right, this is really helpful. Thank you. Okay. I'm curious for the folks on the call. I'm curious as to what you mean when you say boilerplating. I've heard people define it in a few different ways. Which aspects are you talking about boilerplating? If you're willing to unmute and talk about that for a second, I'd love to hear it. And if not, that's quite right.
It's possible I disabled everyone's mic by accident. I switched everyone to an attendee, and I'm still a little fuzzy on what that actually means.
No worries. Feel free to throw it in the chat as we go. And for now, I will say this is okay. This is helpful. So we've got scenarios that depend on different data, dependency management, boilerplating, testing SQL-like code in EF. That's interesting. Okay, and then databases. So we've got a few different questions about data. And combined with the understanding or the less folks being familiar with Spec Flow and less folks talking about acceptance-driven tests, I think perhaps a nice way to start tonight might be doing some Spec Flow acceptance test-driven development on maybe a fake application that uses an EF core against the SQL database. Maybe, yes? All right, so what I will say also is that this talk truly depends on you. So if what I'm doing is not interesting to you or you'd like to move on, one thing I'm going to let you do tonight, and perhaps if I had thought ahead on this, I might have done more of a lean coffee style format where you break every few minutes and kind of give a thumbs up, thumbs down. But since folks aren't on camera, what I'll ask you to do is you can put something in the chat called ELMO, which is an acronym that I love of enough, let's move on. So if we're getting deep into something and you're really starting to fade, you're finding this is not adding value to you, just go ahead and throw Elmo in the chat. I won't be offended. And Lee, if we see a bunch of those pop up and I'm like sharing my screen or something, feel free to kind of reach out to me and say, hey, we're getting a lot of Elmos, and we'll go on from there. All right, great. So given that, what I'm going to do is I'm going to go ahead and pull up an instance of Visual Studio on my machine, and I'll share my screen. And forgive me, I will change, and I will make sure that I zoom in on things as we open them up. So on my right over here, we have just an empty solution for tonight that I've called cap area. And so what we'll do is we'll need to do some kind of a common scenario. I will add a web piece perhaps at the end, but since I want to talk more about the concept of acceptance test-driven development, I'll probably leave the UI out for just right now because I think we can demonstrate it without it, and hopefully we'll be able to get to that at the end. So what I'll do tonight is we'll do some common scenario. Say the first one that comes to mind is typically like a vending machine. That's an example I've used before. It's fairly relatable from the real world to the programmatic world. So we'll have the concept of a vending machine. And so for this, I will have we'll create a new class library, and I'll call that class library. We'll just call it vending machine for now, right? We'll do .NET 6, great. And I will also create a library called vending machine.tests. Now, a couple of things we can do here. Folks, there were a few questions about how to structure test projects. So we can do things a few ways. For the sake of our examples tonight, what I'll probably do is put the tests in one project under folders. But for different types of tests that might run or be built at different times, you may want to do them in separate projects as well. So in our case, rather than vending machine .tests .acceptance, right, or vending machine.test.unit, right? In this case, I'll say vending machine.tests, and we'll have folders within that project for the different types of tests that we're writing. I personally like that because I tend to find that organizing it that way helps me think and get into the right mindset around the kind of tests I want to write. And as we're setting this up, for those of you who are maybe less familiar with those kinds of tests, what I typically mean by acceptance test is a test that tests the entire application using real components end to end and make sure that the test is doing what it needs to do. And so, that the application is doing what it needs to do. Integration tests may be still integrating integrating two or more components together, and a unit test is something that I would expect to be reasonably well isolated from other components. Now, there's some flexibility in this. People are a little dogmatic about the terminology. Personally, I think that unit tests should be completely isolated, and anything that interacts with that test should be faked out. But I'm also okay with having integration tests, right? There's really no right or wrong there as far as I'm concerned. If you're trying to test your application surface and you typically want to have more unit tests and a little bit less integration tests and maybe a little bit less acceptance tests and a little bit less UI tests, because those things UI tests tend to be a little bit brittle. They break a little more often. They break more often for things that are out of your code's control. That might be something entirely unrelated that makes the test a little flaky. And so typically from a test maintenance perspective, we call that the testing pyramid, or if you invert it, we call it the testing funnel, where you try to have many isolated unit tests, slightly less integration tests, so on and so forth. There's a lot of debate about that. And all I'll say is that it really depends on the team's context and the team's challenges with automated testing. For example, I worked with a test that, or a team, an organization that had issues because they were a legacy application and they had difficulty getting their code under automated test. It was not written in a fairly testable way. And so what I suggested there was a sort of more of a Swiss cheese approach, where they write acceptance level tests and UI level tests early on, and then they work to get the code that is underneath of those things covered by unit and integration tests, since they have that top level test. And it'll be a little flaky, it'll take a little bit longer to run, but once you have it covered with some of those lower level tests, you can kind of think about removing some of those acceptance or UI tests. And also, I should mention, there's a lot to pack into these various topics. So I know I'm going to throw a lot of terms out there tonight. Feel free to ask for clarification in the chat. And also bear in mind that I teach, or rather I have taught, a multi-day course on this sort of thing. So there's a lot of ground that you can cover. We're going to try to jump around a little bit, and that may or may not work for you, but feel free to ask clarifying questions or to ask us to stay on a subject for a little while longer. Okay,
so on that point there's, I don't know if now's a good time, but Diego asked a question when we were talking about automated testing about Rainforest QA and Marble, which are actually not frameworks that I'm familiar with. So I thought that was really interesting. It sounds like there's Selenium, but without the coding. And then Niles requested that you zoom in to the text a little bit.
Oh yes, absolutely. Yep. So I will be zooming in for sure. I'll just do it right there. And as far as those other tools, my my preference around that, and again, Diego, it depends on the environment that I'm in. For example, I have been in an environment with incredibly talented QA professionals who had less experience coding. In that case, I might be willing to do more non-code automated testing from that perspective. However, I tend to find that the most effective testing is being done as the code is being written. And I find that when we introduce those kinds of tools, we either get into testing that are done that aren't necessarily covering the exact functionality, or that are being done not in the timeliest manner. And so from my perspective, I prefer automated tests to be done in a timely fashion as close to when the code is written as possible. So I certainly wouldn't disparage those tools or say I'd never use them. I think it depends on your team composition and your mission. I hope that you'll see, in fact, maybe one of the things we can show is this tool, Spec Flow, I find to be a very helpful bridge between what some of those tools do and what we can do in our own code. So we'll start there actually with some Spec Flow tests and get an understanding of how this might work. I do not have an opinion on approvaltest.com only because I have not yet seen approvaltest.com. So interested, I'll check that out. In fact, thanks for posting it in the chat. I'll check it out after this meeting, but I have not heard of approvaltest.com. Typically, my opinion on these automated tests is we can generally do them with free tools that are available to us and to the team. With that and a little bit of collaboration, we've got some opportunities. So typically, I tend to say that the tests can live within our code base, be checked in along with our code base, run alongside our builds and our continuous integration process, and we should be able to pull all of that off. And certainly, I have seen that done without too much pain on our end. So. All right, so given that, let's start. I've been talking about the Spec Flow thing. What the heck is it? So Spec Flow is a tool for writing Gherkin-based automated acceptance tests, or Gherkin-based tests in general. For those of you who aren't familiar with the concept of Gherkin-based tests, what they are is the idea of using a human-readable test with something like given, when, then structure. So for our test for a vending machine, perhaps our first test will be given a product, Pepsi exists in the vending machine and the product costs 50 cents, then when I put 2 quarters into the vending machine and I order a Pepsi, I get the Pepsi, right? So what I've just done there is I've put that notion of a requirement into that syntax of given, when, then. But that's actually really useful because it sets up the world of the test. It tells me what actions I need to take for the test, and it tells me what expectations I should have in the test. And so one of the nice things about that is it really maps well to the idea of arrange, act, and assert in automated testing parlance. So let's take a look at how that might work in action. So I'm going to go ahead and install Spec Flow actually. We'll go ahead and install Spec Flow. In this case, we'll use XUnit. Why not? I'll install it into the vending machine test project. Go ahead and install that. And I'm also going to go ahead. Sure, I will accept the license. Hopefully, there's nothing in the license about not using it for presentations. I'm going to go ahead also and install specflowtools.msbuild. All right. And that should generate our tests. I may need to add one more item, and I never remember which it is. So we'll see if I captured it there. So the first thing I'm going to do, I also have a tool installed here, a Visual Studio extension that is the Spec Flow extension, which gives me some nice highlighting, as hopefully we'll see momentarily. So in my vending machine tests, I'm going to create a new folder. Right, and for those of you who just joined, we're doing some folders inside of a vending machine test project rather than separate test projects themselves. I'll call this acceptance, and I'm going to go ahead and add a new item. And in my Visual Studio here, I should be able to see Spec Flow, and I'm going to add a feature file. All right, and I'm going to add, for now, I'll just call the feature vending. Right, we're done with a vending machine. So we see here a template file for our feature, and we see a short summary of the feature. So maybe what I'll do here is exact change, right? We'll call the feature, or we'll call the feature payments maybe. We can do something here as a vending machine customer. I want to receive the products I pay for so that I can have a tasty beverage. Now we're going to ignore the fact that's a pretty terribly written user story, right? Because I'm demonstrating the tool more than anything. Spec Flow has something called tags that we can use to tag and categorize different features. So as we need to surface them, we can do that. So what we have here is a scenario. So let's think of the scenarios that we might have for our vending machine, right? So I want with exact payment, I can purchase product. Not enough payment, no product. I can return change maybe, right, or releasing change. Get change back when entered. Get correct change back when entered, when returning change. So okay, so we've got a few maybe scenarios that we can deal with here. So let's look at the first scenario, or let's start with not enough payment. So scenario not enough payment, or no, we'll say no product when not enough payment. This is sort of just a general quick description. Sometimes they map pretty well to acceptance criteria. Sometimes you might need a couple. And this is also something that is to be called example-driven development as well. Right? What we're doing is we're trying to use examples, real examples, to drive the features of our product. So here I've got no product when not enough payment. So given a product exists called Pepsi, that costs, or we can say called Pepsi, and the product costs. We'll say the product costs 50 cents. We're just going to we'll do an old school vending machine here. When I place a quarter in the vending machine, and I place a quarter in the vending machine, so it's 2 quarters. Then, and I order a Pepsi, then I should, if a product costs 50 cents, when I place a quarter in the vending machine and I order a Pepsi, then I should not receive a beverage. Or I should not receive the Pepsi, you can say. You can be a little more specific. And I'm realizing, so one of the couple things we can do here, right? We can look at, okay, let's talk about this story. This is a collaborative example that we're looking at. One of the observations someone might make is that, okay, the name Pepsi doesn't really matter in this case. It's really any product, right? So given the product exists and the product costs 50 cents, and I order the product, I should not receive the product. So now we've got our scenario here. We can kind of do some formatting there. What I might do here is build my project. What we see here is that we see some text. The text becomes purple, and that's Spec Flow's way of telling us that we don't have a step defined for this yet. And so I'm going to go ahead and I hit F12 as if I could go to that piece of code. I hit F12, and it says this step is undefined. Would you like to copy a step definition? Well, that's very helpful, Spec Flow. Yes, thank you. I'm going to go ahead and I'm going to add in my project a Spec Flow steps file. We can see a Spec Flow configuration file, a speaker file, and actually I'm just going to create a class here, and I'm going to call it within my acceptance test folder. I'm going to call it vending machine steps.cs. And all I need to do here, I'm going to make this class public, and what I need to do here is add something that comes from Spec Flow called binding. This tells Spec Flow to make these steps, the steps in this class, available to its Spec Flow tests. So I'm going to go ahead and paste that there. What we can see here is we match that given phrase to a product exists, right, which is what we wrote here, and that is going to execute this code, right? So given a product exists, so probably while we're doing that here, we'll say, to do add product to database. So I have some to-dos there. And the product costs 50 cents. So again, we'll hit F12, we'll copy that step, and the product costs 50 cents. Oops. And now you can see a couple cool things that Spec Flow did there. The product costs X amount of cents. It automatically did some regex there, extracted that out, and we're getting that passed into our code here as an integer parameter. Right, so we can go ahead and see there the product costs X amount of cents. We now can make a product that costs 50 cents or 75 cents or however we want to do it. And then inside here, we're going to want to say, to do right, set product price. And this is something we're going to want to do within a real database, right? So we'll have to figure out how to do that, but we should be able to get there. When I place a quarter in the vending machine, so don't mind me, I'm just going to do these last couple copy paste steps here. I place a quarter in the vending machine to do insert quarter. All right. Similarly there, and I order the product. Then I should not receive the product. Now here in this case, we're going to have the idea of a vending machine that sort of returns. We'll cheat a little bit. We'll say it returns null, just so we can kind of understand what not a product means or not getting a product means. So what are the ways that we can do this? Well, we want this to be a real test, right? And so we don't have any vending machine that exists yet. So what we could do, we could choose to do this in a couple of ways. We could choose to write this piece without the data piece, right? Without adding that database module, and then we could add that later. Or we could start by creating the database and then sort of, pseudo writing out some of that database code and having that work. What I'm going to do for the sake of this example and showing it is I'm going to do it without the database first, and then we'll add that database module in. So we'll go ahead and TDD our vending machine. So now we've got a failing acceptance test. If I was to run this test, it's going to fail because we have those pieces are not implemented exceptions, right? So those tests would fail. So let's go ahead and write just enough for it to fail in the way that we want it to. So given a product exists, we'll have this idea of a product that exists here. So we'll just do real quick public class, or we'll use a record. Yay! Public record product, which has a string name, and we'll say a decimal price. In fact, for our sake, we'll just simplify it even further, and we'll just say it's an int price. So when someone says given product exists, we'll have a product that is part of this class, and we'll say product equals new product. We need a name for it, and we'll say, okay, the name is test product. And the cost, it doesn't matter now. We haven't set the step, right? So it's going to be 0. And then given the product costs that sense, so we'll say product equals, we'll use some record syntax here. Product equals product with, I think we can do in that, right? With price equals, P0 is a terrible name for that variable. So what we'll do is we'll say product, we'll rename that variable to product price. All right, so now we've got that set. When I place a quarter in the vending machine, okay, so there's this idea of a vending machine that's going to exist here. So by the way, you'll notice a couple things I'm doing. I'm totally happy messily having this production code starting in my test file. I'm okay with graduating that to the other product later. Sometimes people say, okay, well, you need to put it in the other project and reference it. I'm more loosey-goosey about that because I'm going to move it afterwards, and that's fine with me. Some folks really feel strongly that you have to put the production code in that project to start with, but I'm just not as worried about that. So for now, we'll have, okay, so we know that a vending machine has to exist. No idea what it does yet. I also know that that vending machine probably has to be instantiated, so we're going to use a tool called before scenario. That means before every scenario, Spec Flow is going to run this piece of code. So before any one of those examples that we write, Spec Flow is going to run this piece of code. So in our case, we're going to say vending machine equals new vending machine. When I place a quarter in the vending machine, so we'll say, okay, vending machine dot insert coin, insert quarter, we'll say, right? Because again, we're simplifying for this example, right? Vending machine dot insert quarter. When I order a product, we'll say there, we'll say, okay, so we have to have the idea of some result right? So we'll say we have a product that may or may not be null, right? We'll call it result for now. When I place an order in the vending machine, when I order the product, we'll say product equals vending machine dot get product. Sure, we'll just, we'll kind of fake this as we go along. We can rename it later. Then I should not receive the product. And since we said should not receive, we'll say we don't want product, we want to call this results. And then I should not receive the product, so we'll say result. And here's where I introduce another testing tool that I love, and I'm going to call, and that is a tool called Fluent Assertions. If you've never used Fluent Assertions, I just happen to love it. We don't have to use it because different testing libraries have assertion libraries, but I just happen to really like Fluent Assertions because it lets me do result.should be null. I just happen to really like that syntax for things. We have similar to should be. Yes, correctly. Yeah, very, very similar mindset there. So what we have the kind of the makings of things here. Our test, of course, will fail at this point. In fact, I'm going to use another tool here that I happen to enjoy very much called NCrunch. If you haven't used NCrunch before, we'll give them some free advertisements here because I absolutely love the product. So what NCrunch is doing is it's going to helpfully run all my tests in real time as I type. And that's really helpful for me when you think about feedback loops on testing. To have to build your project and run your project and wait for the test to run, it can be a bit of a long loop when you've got a lot of different projects. And so in our case, we've got vending machine tests here. It's actually building that project, and it's going to keep building that project every time I run it. Is NCrunch free? No, it is not, but I have to tell you, it's some of the best money I have spent for a product. For the productivity alone that I get, I cannot recommend it enough. It also, in most cases, can intelligently rerun only the tests that have been affected by your code changes. So if you've got a large test library, it does a phenomenal job of paring down the tests that need to be run, which gives you that really lightning quick feedback. Yes, and Doc ReSharper does also have this. I find NCrunches to be a little fast enough to make it worth me paying for it in addition to ReSharper worthwhile. So we've got NCrunch, which is telling us at this point that our project won't build because, correct, it's not building. We'll go ahead and say, we'll add the method for insert quarter, right? We're gonna have it throw an exception for now. And we'll insert the method for get product. We'll say product. All right, and we'll have it throw an exception too because why not? Right. And so now what we see here, this helpful little guideline is this NCrunch here on the left-hand side, and in the bottom showing us, hey, the test is failing. And not only is my Spec Flow test failing, it'll read the scenario, it'll tell me where, and then it'll actually highlight the line on which the test is failing, which is super helpful. Of course, it's failing here because I've thrown an exception. All right, so how do we do this sort of without a database? Well, we've got our feature now. So the next question is, okay, how would we maybe TDD this at a unit test level, right? Now, in this case, we're sort of we're allowing ourselves to not do a database and not do those things. So if I was building up to that, I might TDD this at the unit testing level a little differently. But so let's go ahead and look at maybe what a unit test might look like for this vending machine. So let's go ahead and I'll create another folder here. We've got a failing acceptance test. So what I'm doing now is I'm sort of transitioning from the outer layer of my vending machine test to an inner layer of my vending machine test. Now the two layers are going to look pretty similar. One, because this is a contrived example, but two, because we haven't really added a ton of functionality yet where they would diverge. But I'm going to go ahead and create a new folder here, and we'll explore that for a bit. So a folder for our unit tests, and I'll also have a file here that I'll just call, it will call vending machine.unit. In our case, vending machine.unit.cs. And I'm giving them a separate name just because I didn't want to have two vending machine test files. Don't mind me there, I'll just call it vending machine. All right, so ask for vending machine test. Now, typically, in terms of naming and organization, what I might want to do here is I would have acceptance in a different project, and I would have acceptance tests for the vending machine, and I would call that vending machine. And then I would have a unit test project, and I would have a class in that unit test project called vending machine. So typically I would not put unit on the end of this. That's an artifact of us doing tests in a slightly, just compressing it all into one test project there. So let's go ahead and look at what we might do here for an X unit test along those lines. So let's look and say, so we have to, by the way, one thing we haven't done in our vending machine steps, right? We haven't done anything about, we said a product exists. We probably should add this product to the vending machine. Okay, so we'll have to do something like vending machine.add products product. So I'm going to add that there. We don't, again, nothing really exists. None of it really works yet. That was just enough to get our first acceptance test to failing. Right, so we've got a red test. It does what we think it should do, but we have no real code to do anything yet. Right. So now how are we going to test this vending machine? So the way I would see that is we have XUnit allows us to organize. We're going to use XUnit in this example, but I can also show NUnit if you prefer. So we can organize our tests in a different way with XUnit. I really like the ability to do some nested classes with an XUnit to kind of break down which methods and names we're testing. So there are some things that we can do there. So let's first test. I mean, we can pick any method we want here in our vending machine. We could do insert quarter, we could do get products, but you know what I realized here as I go into it, and this is, by the way, I'm doing this out loud, and I've done this example before. One of the reasons we do these examples over and over again is we think about different ways to do it, we think out loud, and I'm purposefully, and in some cases not purposefully, right, realizing some of these things as I go to show you also that the thinking should evolve, and this is a thought process that we do out loud. For example, how can I was going to say, let's start with insert quarter, but how can I really tell that insert quarter does anything? Right? What is the side effect of insert quarter? Sure, maybe I could create a public property that has the current amount in the vending machine, but that's kind of cheating. That's not really what I'm trying to do. I'm not trying to expose that functionality. But we did have a method later on that we could test called release change. Right? So I'm going to test the insert quarter part of our acceptance test, but I'm going to do it using the release change method, which doesn't currently exist. So this is what I mean when I say we're sort of stepping from an outer layer of this acceptance test that is failing, and now we're zooming in and we're building up little pieces to get to the spot where that vending machine, where that acceptance test actually passes. So in this case, I'm going to create a class that represents the tests we're going to do for the method called release change, which does not exist yet on our vending machine. So how am I going to set up this test? Well, first what we want to do is we know we're going to have a vending machine that we're going to test. Right? So we're going to, go ahead and say I'm going to have a private vending machine, and I'm going to call that a certain variable name. Now, the name that I tend to give those things is sut or situation under test, and that's because I tend to find that writing vending machine underscore vending machine or it kind of gets a little old. And so what I do is I use that prefix for situation under test, and that's how I tend to refer to what we're testing. I think I have already probably picked the wrong class here, but that's okay. We'll work on that as we go. So what I'm going to do here is XUnit has an attribute called fact. That's how we state that something is going to be true in XUnit. I'm sorry. Okay. And so we're going to have public void here, and that public void is going to be let's think about what we want to do here. So we're testing the release change method, right? And so let's say when no change, no quarter is added, no change given, right? So release change is the method we're testing. When no quarters are added, then no change is given, what we call release change. Right, so how are we going to set that up? Well, before every single test in XUnit, right, we want to instantiate that vending machine. So XUnit does that using the constructor of a class. So okay, so we've got a new vending machine there, and then we're gonna instantiate our that up there. We're going to we've instantiated our situation under test as a vending machine. So when no quarters are added, so we're not going to do anything in the setup of this, no change given. So we're going to say, var result equals vending machine or set.release change. And then we'll say result dot should be 0. Right, so that's our first test there to get inside of this loop. Now, of course, I have done something with a global namespace that I did not mean to do. Public class release change has a, well, now I am. Okay. Vending machine, same names. What am I missing here? I know I'm missing. All right, well, now's a good time as I need to say, okay, I'm obviously screwing something up. So I'm going to go ahead and move that vending machine class into here. I'm going to go ahead and move the product record into my production code as well. I'm going to go ahead and add that down here. And now I'm going to add a reference from my test project to my production code project, which I'm going to do by saying add project reference. I'm going to reference my production code project from my test project. All right, so now let's see what that clears up for us. I have a feeling that will do some good work there. Okay, so if I go back to my vending machine tests, what am I missing here? Let's just try to simplify things. Vending machine. And let's go ahead and take this fact. Oh, silly me. I don't know that I installed XUnit in my project, my test project. That would help. Let's go ahead and install package XUnits. Okay. So let's go ahead and I'm going to re-add this here. And I'm going to try to understand why I'm having compiler errors. And by all means, if I'm flummoxed enough by this that I'm just going to delete it and I'll copy my facts. I'm going to delete it. I feel like there's a global namespacing that I did by accident, and I don't know where that would be. So let's go ahead and this is how it always goes when there's enough hubris to do a live demo. Even the simple things can go wrong.
Every single time.
Right. So we've got our public class vending machine test. We won't nest our classes. I'll go ahead and import that. Okay, so we've got our fact here, right? We don't have our set variable defined. So we're going to go ahead and say vending machine. I'm going to double check, right? That's the class of vending machine, dot vending machine. All right, great. This is what I would expect. Now, I'm not sure what happened there. Something with the namespacing, I'm sure, but something I did not see happen. And so would have taken me a minute. All right, so let's go ahead, right? We see here that release change is not quite working here, right? Because it does not exist. So let's go ahead and create that. So on our production code here, we're going to say that release change returns an int, and we'll have this exception here because we should be able to rebuild this project, add Fluent Assertions, and we should be able to see now that our ncrunch test, when we reload things, okay, so this appears to be ncrunch that is having the issue here. Not to worry, let's go ahead and disable ncrunch and re-enable, which is interesting. I can't say I've actually ever seen it have that problem before doing something basic. So quite interesting. So anyway, what we can do here, I've also got the resharper test runner if we need it. My release change method converted back to object from int. Well, that'll do it, won't it? Thank you. Great eyes. Great eyes, Diego. All right, so we'll still keep that as int here. And what I don't understand ncrunch doing is saying that vending machine is an, oh, I know why. It is because, I see. What I'm going to do is I'm going to call this, it's a name thing. It's because I'm calling it vending machine, and that was the name of the project, I think. So let's just try, we'll call it the cap area vending machine. And we'll go ahead and so now we've got the build succeeding. Let's go ahead and reload that, see if we can. Interesting. Not sure what's going on there. Okay, well, we'll have to bail on ncrunch for now, which is interesting because that was.
Well, that one needs to go back to vending machine. You've got it using the namespace there, don't you? Wasn't the namespace cap area vending machine?
No, the namespace is vending machine. It's because I called it, then the namespace is vending machine, so I called this vending machine. So now I'm seeing that in vending machine test, the type or namespace could not be found. Am I missing a directive? But I'm not, because I obviously just built in Visual Studio. But let's go ahead then, and we'll just, for the sake of this, I don't want to spend too much time with tooling. So we'll go back to our unit tests here, and we'll have resharper run all of our tests for the solution, which is totally fine. I have a feeling it cached something strange when I had that problem and is now struggling to have the issue there. Okay. Resharper tests. Unit tests. Oh, I have a unit test explorer that is showing over here in my other window. Do not know why it is detached. There we go. So let's go ahead. And now we can see, interesting, that none of the tests are running. Well, this is just phenomenal. Go ahead and see. Okay. So I think in this case, what we're missing then is a package for running the XUnit tests as well. So let's go ahead to our NuGet packages. And XUnit has an XUnit runner for Visual Studio, I believe. So let's go ahead and we'll add the analyzers package as well. Okay, and unit.runner.visual studio, xunit rather .runner.visual studio is now installed as well. Go ahead and build that, and now we should be able to see and run those tests. Or I'm having a really great night, and we're going to get held up at this spot in things. Okay. Let's understand what's going on here then. Let's go ahead and rebuild our solution from scratch. It is working. Our vending machine tests have a set. I'm going to click on this and say run tests. See, Visual Studio discovers our tests here. And it does not. Well, this is delightful. Let's go ahead and, for the sake of time, I'm going to go ahead and, well, first we're going to do the obvious. I'm going to restart Visual Studio and see if there's something strange going on there. It's always a humbling experience doing a live talk, always. Not normally quite this humbling, but always humbling.
Been there, done that.
Okay.
Happens to the best of them.
So we're still building, still see InCrunch engine is initializing. It is rebuilding. Hey, look at that. It rebuilt correctly and we have failed tests as I would expect. Okay, cool. Thanks for whatever happened there, Visual Studio. So what we see here for our first test is we're failing because we're throwing an exception on that code. So I will give it, oh, sorry, I saw in the chat they were asking, can we still show the nested class setup for XUnit? And absolutely, I will do that now that it works. So since XUnit works based on C# class structure, we can nest this class here, and I could create another class called release change. Right. And I'll go ahead and copy this into that class here. Okay, incorrect designation there. And we see here that under the vending machine test.unit, vending machine test plus release change. So it generates, and I'm sorry, the text is a little small. If I can zoom in on that there. So under the, you can see there that the vending machine test.release change has that plus symbol in there. And so we can kind of test that way that things are happening. And now, of course, I have a triple monitor setup where that magnifying is not, the magnifying app is preventing me from closing it. So this is really just truly a learning one, apparently, a learning talk. So, okay. So now let's go ahead and make that test pass. We want to release change, right? No quarters have added, right? Then the result should be 0. Let's go ahead and just return 0, return 0. And we'll see NCrunch is running, and we'll see here, we still see object reference not set to an instance of an object because in the constructor here, I didn't instantiate it. So let's go ahead and create a constructor here, right? Because we didn't instantiate our. And now, okay, so I'm instantiating that object, and now I call release change at 0. You see that immediate feedback from NCrunch, which I really like. I'm also going to go ahead and make a new tab group there with our production code, so we can kind of see a little better in terms of what we're trying to do. All right, so next up, we'll do another fact, right? When 1 quarter is added, should be 25 returned. Right. So that result, or so we'll say, so we've already instantiated it in our constructor there, so we can assume it's instantiated. So we'll call set.insert quarter, and then we'll say that result equals set.release change. Result dot should be 25. We'll finish that, and that should fail pretty quickly. We see here calling insert quarter throws an exception still. So we can go up here and we can say, okay, now we've got this idea of, what is the simplest thing I can do to make this test pass? Well, I can go ahead and remove that exception, right? And then the test will fail because it's 0 when it should be 25. So we could, how could I fake this test out and still say that I'm not done, right? So at that point, I would say, okay, so let's just go ahead and say int change equals 0. When I insert a quarter, we'll say change is equal to 25. Right? Now it's obviously wrong. I want to increase it by 25, but I'm setting it equal to 25 because it just kind of let me know I'm not done yet, right? I was able to fake out my code. I'll say return change. So the test will pass, but I'm not done yet with what I'm doing here. And so we'll go on for this for a little bit, right? So public void when 2 quarters entered, right, should be 50. Release change should be 50. Right, so this is where we can kind of get, okay, I could do 3 quarters, 4 quarters, 5 quarters, whatever. But you'll note what I didn't do is create a test that has a loop in it, where we just specify the number and then it kind of iterates through for us as a test. Now, the reason we do that is because I want to be very explicit about the business case here, and because I want to put as little production code as possible, including like loops and branching statements in my tests themselves. So whenever possible, I want to have an additional test that will triangulate that behavior rather than producing a loop or some kind of other control structure in my test. So let's go ahead here, and for this case, I'm going to copy this. Someone mentioned dry versus wet in the feedback, and one thing I want to mention here is the idea of damp, which I think came from Mark Seaman. But the idea of dry, don't repeat yourself, versus damp, descriptive and meaningful phrasing. And while it's a contrived acronym, I really appreciate it because the point of tests, in my opinion, is readability and understandability. So if by repeating some code and not extracting that into a method somewhere down below my class, I can keep the test readable, I want to make sure that I do that. Okay, so let's go ahead here and update our tests, right? It's going to fail because it's going to be 25. So now let's go ahead, increment. Right, and in this case, right, I could do 3 more. I could add an if statement here if I wanted to and try to be clever about it. But in this case, we'll have it increment by 25. Okay, so now we have the idea of getting a product. I see here I've got some refactoring I can do. Resharper is telling me I can do some stuff. I've got some passing tests, so I'll take Resharper up on his advice. I'll make this into a read-only variable, and now I can see I'm still getting that immediate feedback on my test, right? So that's an important part of what test-driven development is doing for us. So let's assume we've got the rest of this, right, release change stuff done. The next step would then be, right, what is still failing, right, in my other test, right? So I've got the idea of getting a product, right? And then I've got the idea of adding a product. And for this first test, all I care about in my vending machine feature file is that a product exists and the product costs 50 cents. So add product is something that has to exist and it has to take a product, right? So what do I care about right now? Can I just make that do nothing? Let's see, right? So if then the product costs 50 cents. When I place a quarter in the vending machine, which we have insert quarter, and I order the product of get product, then I should not receive the product. So let's go ahead and say return null. Okay. Have I done the simplest thing now that makes this acceptance testing scenario pass? Yes, I have, because I don't need to do anything more than that to make this loop for this one scenario pass. Obviously, I still have work to do, right? So now let's say, okay, products, gonna copy and paste again. Product when enough payment. Given a product exists and the product costs 50 cents, when I place a quarter in the vending machine, and I can repeat this step, I could do 2 things. I could create a step that says when I place X amount of quarters in the vending machine, or I could just repeat that step again. So I'm going to go ahead and repeat that step again. And also, Spec Flow here is giving us some IntelliSense, which is nice. So I can just hit enter and make that happen. And then rather than saying when I order the product, rather than I should not receive the product, we want to say I should receive the product. We have not defined that step yet, so we'll do that same thing that Spec Flow lets us do. We'll copy that. We'll go into our steps file here. We'll scroll down to our then statements, and we'll say I should receive the product. And what we want to say is result. And in this case, we'll just say not be null. That's what indicates that we received the product. Now, of course, it's going to fail, right? Because we haven't yet done the things that make it that are necessary for it to do those things. So we're going to go ahead and go back into that loop and figure out where in our unit test what we need to do. Right. So from a unit test perspective, we need to now again in this case add product is kind of we don't really need it necessarily because we're assuming a product and we're not adding multiple products yet, so we don't quite need it. But we could go to the idea of get product here. So get product, the result should not be null, right? We have in some cases it returns null, in some cases it doesn't. So now let's go ahead and say if change greater than equal to 50, return new product. Right, we're kind of using the same product record, right? So we can see here, there's messy stuff, right? But I'm not allowing myself to get bogged down in that because that's all stuff that can get refactored later. Yes, we could be a little tidier about it. Yes, I'm doing a live demo, right? If I'm not talking out loud and doing it, would I do it a little differently? Maybe. But one of the important things there is that none of this is stuff that can't be refactored, especially once we have tests built up. Right. Okay, so now we've got our next test passing. Right, but we don't, it's kind of like right now we're assuming the cost of our product is 50 cents, right? So let's go through, when I rebuild, we'll see that this IntelliSense disappears there. Go ahead and say product when, we can actually probably do this in a couple different ways. We're going to introduce the idea of an example to Spec Flow. What we're really trying to say is, right, when there's enough payments, then we have enough, right? We have all of the things that we need and we get the product. So let's go ahead and turn this into an example. We're going to go ahead and say that when the product cost cents, place a quarter, and we are going to do, and I place quarter amount quarters in the vending machine. Then I order the product, then I should receive the product. Now what we have here is we can actually do examples, and then we can say product cost. In this case, we'll have product cost and we'll have a quarter amount. So if the product costs 50 cents and the quarter amount is 2, or if the product costs 75 cents and the quarter amount is 3, or if the product costs 100 cents and the quarter amount is 4, right? Now, in this case, I'm a little more amenable to saying when I place X amount of quarters and doing a little loop, because this is allowing us to think a little bit more like a person might think, right? We don't say, and I insert the quarter, and I insert the quarter, and I insert the quarter. Someone's going to say, and I insert 3 or 4 quarters. So I'm okay in this scenario because we're dealing with more human readable stuff to do that. So let's go ahead and add a step here. When I place blank, X amount of quarters into the vending machine. So I did that copy again. When I place blank, X amount of quarters, and I'll go ahead and call this variable quarter amount, right? So we can say, right, for I, for each, there's a array, or not for each, is it? I know I'm blanking because I'm just doing this live, but there's a sets where you can do for one to
enumerable dot isn't there a, oh yeah, you got it.
Oh, that's it, yeah, thank you. Numerable dots range 1 quarter amount for, I think I can do that right in the for loop there. Can I do that?
I don't think you do it in a for loop. Normally that's a functional thing. So you do enumerable dot range, and then you do a link thing on top of it.
Thank you. Okay, you know what? Fine, I'll just do that for now. I'm okay with that. For each, we're not going to worry about that. We're going to say vending machine dot insert quarter. Right, and so again, this is messy, right? It's gross. I didn't even remember how to do it, right? But what matters right now is that test is passing. And now I can go ahead, I could refactor this, right? I could repeat that, I could extract that out, I could replace it with an actual loop that actually matters, right? One of those things could happen, right? For the sake of this time, I'm not going to do that, but that's exactly what the next step would typically be for me to do. I'm going to also just go ahead and indent that correctly. All right, so now we've got some scenarios here. And so at this point, right, I want to switch gears to say, okay, how do we do this? How do we do this with a database, right? Because we've got, a lot of different things we could cover, but folks had asked specifically about databases. So when we have a vending machine, presumably it would have something like a vending machine context or something along those lines, right? So let's go ahead and for this case, we will say for our vending machine, we'll have some integration tests here that we do. And let's go ahead and say that our vending machine also has a data holder that holds its change, right? So let's go ahead and now we're going to introduce the idea that a vending machine has a change holder. So we're going to go ahead and say public cap area vending machine. We'll say change holder, and this may be the class that typically talks to a database or something along those lines, right? And so I'll go ahead and create a new class here called class change holder, right? We'll have a public maybe amount, and for now we'll just do a get in a set. Public int amount get set. And so what we do here at this point, right, is we now have this idea of a change holder. In fact, let's not do that. Let's do now. Let's back up a little bit. I'm getting ahead of myself, right? I am writing production code for this change holder class, right? And I haven't introduced any unit tests for it, right? So the next thing I would do is I would create here a unit test here. I would say, okay, I'm going to need a change holder, right? And that change holder is going to need to, we'll call it change holder tests. A change holder is going to need to be able to add increment amounts, right? So we'll say what we'll need to do is, in fact, public void add amount. Well, actually, we can probably do a class there. Oh, we'll keep it here. Public void add amount when 25 when I would normally make this into like 10 different tests, but we'll just skip ahead. When 25 and adding 25 results return. We'll actually say we'll need we'll have to get the amount, right? Get current change. Get current change when 25 and adding 25 returns 50, for example. Right, and we'll add our fact attribute. We'll have to say situation under test equals new change holder, change holder. We'll say 10 and adding 25. Add 25. Turns 25. 25 get change should be 50, right? I didn't split that into a separate variable this time. We'll add that method there. For the sake of this, I'm just going to go ahead and make it pass maybe more right off the bat than I normally would. So we've got this idea of adding and getting change, right? That test is going to now we'll import Fluent Assertions. Okay. Oh, sorry, I probably should make that a void. That would help. All right, and so set.getChange returns is not a void anymore. Right? We want that to be an int, and we'll have this idea of returning private ints of change. Now you can imagine this might be getting something from a database, right? It might be doing some other things. And we're going to go ahead and for this case, we'll go ahead and implement it right off the bat, though typically we'd add some additional unit tests, right? And in this case, for get change, we'll say return so we should see here, right? We say, oh, we don't want it to be 50, it should be 25 because we're starting with 0 and then we're adding 25. Right, so it changes, and we'll write one more test that it's going to pass the first time, right, which is a smell for us. So it's going to pass the first time when adding 25 twice returns 50. So we're going to say add 25, result should be 50. And it will, but I wrote a test and the first time and it passed, right? We typically want our test to fail so that we know we're writing against the right thing. So what I could do here is I could change that real quick and make sure the test fails for the reason I expect it to. Oh, sorry, see, I changed it in the wrong spot, right? And that wasn't what we wanted to do. I want to, in my change holder here, I will go ahead and set that. It should fail. The second one fails because it's 25 instead of 50. That's exactly what I wanted. So now I can go back and change that. Typically, if a test passes the first time, I want to do that right off the bat. And so, okay, so how do we sort of integrate this into our larger, let's assume that we have the larger item, right? So now I'm going to refactor my vending machine. And I'm going to go ahead and add this change machine into the process. So let's go ahead and write var change machine equals new change machine. Call it change holder. And now we're going to have the cap area vending machine take in that change holder. It doesn't currently do that yet. Let's go ahead and open that up. So it's going to say, now we're going to pass in that change holder. All right, we'll take that in here, private change holder. We'll get rid of that int because we're not using it anymore. And I'm doing this pretty quickly also to show that I do this pretty confidently because I'm being guided by these tests. So insert quarter, we can do change holder.add 25. And then for get product, we can say if change holder dot get change equals 50. And then for release change, we should say return change holder dot get change. Right, we'll also have to add an amount or a test later to make sure that goes to 0, right? That the change holder can be reset to 0 when it returns change to us, for example. And so what I wanted to show there, though, is the fact that we could, of course, it helps if now I have to update my tests, right? Because I have vending machine tests here that doesn't actually add those items. And so I have to do that in our production code as well. That's kind of turning this unit test into a integration test, right? So I have a couple options here. For my unit test sake, typically what I want to do is I want to say, okay, well, I want that isolated. I want that under my control. I want to make sure that's always operating as I expect it to operate. And so what I would do here is I would create a public interface. Maybe we'll call it change holder for now, even though it doesn't have to be a one-to-one, right? And we know that it's going to be an int for get change. A void for add with an int amount of change, right? And so now what I want to do is in my capital area vending machine, I want to update that to an I change holder. I'm relying on a contract rather than an instantiated type. All right, I've got my change holder here, still the same thing there. And then rather than instantiating a real change holder here, I have the idea of a mock change holder for which I'm going to use a mocking library. So I'm going to go ahead and install mock. And so I'm going to have a private mock of my I change holder. All right. And then in my construction or in my constructor here, I'm going to say mock change holder. That I'll remove my parentheses. Mock change holder equals new mock change holder. And I'm going to pass into my vending machine the mock change holder.object. Because at the unit test level, I want all of those dependencies to be faked. So now what needs to happen? Double check where my build errors are. I'm sure I'm forgetting one more spot. Oh, new. And so then, I do that. It would help if I had the real class implement the interface. There we go. And now we see our tests are, we've got some failing tests here because I'm not setting up the mock change holder ahead of time. So the nature of our test sort of changes here. Right now we say when 1/4 added should be 25, but really now what we're saying is when 25 is in the change holder, it should return 25. And so here, instead, we're going to set up the mock change holder to say that the mock change holder, whenever the vending machine asks for the amount of change, it's always going to return 25. And so we're not worried about calling insert quarter anymore because really we're sort of doing what the mock, we're relying on that mock for some things. So that's an example of turning it into a unit, keeping it as a unit test and isolate it. Typically what I might do is copy what I have into an integration test project and use a real instantiated object there as well. And that way I've got sort of my isolated test for a unit's sake, and I've got my integration test there. And I do apologize. I think one of the things that understanding about getting into this is that we weren't really touching on so much of the database pieces. So I don't want to leave you without that information, and I'm happy to follow up and do an additional demo. And I kind of think I'm going to record a screencast out of guilt for not getting to it in depth tonight. But one of the things we want to do when dealing with a database is we can still, we pass in, there's still an object that maybe retrieves that change from a database. It's our database-based change retriever that's still, or change holder, that still implements that change holder interface. The difference is that takes in a database connection, right, or a context to do its work, but it still has those same methods of add steps, add change, and and get the change. And so I think what we would do at that point, I'm going to go ahead and kill the screen share real quick. What we would do at that point is we want to, we'd still have our mock test, right? We still have our change holder test in place for isolation, and we could have two sets of integration tests. One could be this set of tests with a with the in-memory change holder that we just created. The other could be a set of tests where we pass in the change holder database context, right? And it has the implementation for those methods, and it uses the database. And in that case, our setups might change a little bit. When we say it should have X amount, right? We might call the add change method on that, and then it calls the database. Or we might do some other code behind the scenes to run a SQL statement against that database context, and that's sort of how we need to do our setup there for that sake. But one thing that I do want to mention about in database context and doing some of that testing is that when you have a database, especially a SQL database, one of the best friends that you will have is the idea of running your tests within a transaction scope. And so at the start of a test or in your setup for your test method, you will typically, if you're using a SQL database, you'll want to find a way to declare a new transaction scope. And the reason for that is at the end of your tests in NUnit, that's called a teardown method, and in XUnit, you can use iDisposable and use the dispose method. But either way, when you're wrapping up your tests and doing that sort of teardown or that disposal, you can roll back the transaction. And having your test perform database operations within a transaction that then gets rolled back is extremely helpful, because what you can do is execute a number of tests in parallel, read the results, and then roll back the transaction rather than worrying about subsequent tests going ahead and stepping on your additional data that you've added. And so when you think about the data lifecycle for tests, you want to think about it in terms of setting up, your tests or your CI process should be able to instantiate your database and all of its schema to an empty database. They should then be able to call a script or programmatically to restore your basic information, things like status codes and states and the kind of things that you find in like list tables or reference tables. And then you may want to add some centralized test data to support all of your test cases, or within the space of these transactions, you can add and modify that data as you need. And so that's one tip I want to leave you with. And I do apologize because I know, realizing that this could be a 3-day course and going through all of these steps is something that is we weren't able to quite get into it tonight. But I do think that I'll have what I will do. is for the people who are in this chat and in the meetup, what I'm going to do is I will go ahead and post a few articles and a few reference links. And I'm already now committing to doing a screencast where I show some of these other libraries that we weren't able to show tonight. So just from a data perspective lifecycle, do think about it in terms of that, the setup there, creating a transaction in the teardown or disposal, throwing that transaction away and rolling it back. But I do hope we were at least able to talk through some of the live refactoring and how we might think about mocking things out or doing things at the unit test level. And we did do at least one round of doing an acceptance test and then doing some unit and integration tests to build up to where that acceptance test passed, and then doing some refactoring knowing that we were covered by that acceptance test. There was one other, so I hope this answered one of the questions ahead of the meetup tonight, was about it being difficult to come up with meaningful tests and mocks. And hopefully by showing this process of starting with the acceptance criteria and thinking through the different components that would make up that transaction, hopefully that's given at least a little insight into how we might think about meaningful tests and mocks versus sort of like, hey, where do I start? And with that, I know we're sort of at the end for our time. And I'm going to be honest with you, I'm not really satisfied with how this went. I feel like there's a lot more we could discuss, and I feel like there's a lot more we could do here. And so what I'm going to commit to you as a group is writing up some, or at least linking to some articles and some things on this. And then with the follow-up, based on what you told me in this chat, I'm going to probably do a series of screencasts on how we might demonstrate that, where we've got a project already set up and we maybe apply some of those principles so that you can get a more in-depth understanding of some of the things I was going to talk to you about tonight. So with that, I will say, Lee, it was an adventure. I don't think it was the adventure I quite thought it would be, but I do hope that folks got something out of it. And if not, by the way, please feel free to let me know what you were hoping to get out of it. And I'm happy to follow up because I am passionate about testing in TDD and thinking through these items, and happy to think through them out loud again with you as a group. So.
Yay, thank you very much. Any questions? I thought that went well. I thought that was really interesting. I especially liked just the hands-on, visual of like how you get the spec flow and the gherkin, and then build that into reuse those things in the test scenarios. That was really cool. So,
well, thank you. And and I will do actually, if you want a more in-depth walkthrough of maybe how I would think through TDD of a problem that's more around unit testing, I will post a blog post that I did around the holidays in the chat. And that is an article that walks through with both XUnit and unit how I would do a problem for what I think I called it the Santa sleigh problem. It's sort of a take on the Mars rover kata. And so if you're looking for something step-by-step that's sort of like, here's how I thought about those tests in order, it's got a Git repository with tagged commits. You can check it out at each step along the way. It's a little more in-depth and definitely a bit more structured than we were doing tonight. So hope to follow up with you all on this. Happy to take additional questions here or later and to go from there. So thank you for your attention and your engagement, and really happy to continue this conversation. I find whenever I talk about this stuff, I do always wish that we had 3 days to talk about it, but I would definitely have you all asleep by that point.
Awesome. Thank you so much. Thanks everybody for coming out. And we will see you again next
question.
week.
Can you hear me?
Yeah.
Yes.
Okay.
Yes, we can hear you.
How these codes are, like how the tests are lined up. So I know like we do a lot of katas. I have done some katas and all those things, but when we talk about the real world, it is inherently very complex. And that's where we face a challenge, like because as we go adding more features, it kind of like slows down. So just wanted to understand, and I think that's the same question I had when we started, like how to put the test so that it doesn't stop you or slow you down. Tests are meant to go faster, but then yeah, that's
a fantastic question. And typically the way I address that is I say we think of there's the theoretical part of it and there's the practical part of it. So the theoretical part is tests definitely do help us go faster, right? Because they serve as that kind of safety net, that safety harness. And so that allows us to move with confidence. Like one of the things we saw, I think, is that, I was like, okay, enumerable for each, right? Like I didn't remember the syntax for that off the top of my head. I've done it 100 times, right? But it doesn't matter. And so it's like, once that, I can just do it the way it needs to be done to get the test to pass, and I can move on and I can refactor it later. And so that's, and certainly I would do that probably shortly after I got the test to pass. And so one of the nice things about that, it does give us the confidence to continue. Now, in an existing code base, you mentioned sort of the time it takes to run and tests slowing us down. There are a couple ways to deal with that. One is that tests are production code. Right. And so we want to maintain them alongside our production code. If we're doing things that are wasteful or taking a long time, we want to clean that up. So particularly, I mentioned the transaction piece for data management. A lot of times what I'll see is integration suites of tests that are taking a long time or that are very flaky because those tests are dependent on each other because they're inserting data into a database. So typically when I work with organizations to refactor towards some of that data management lifecycle stuff that I had mentioned towards the end, what we see is, okay, now we're doing things in transactions and we can run 100 tests in parallel, knowing that they're not going to step on each other, and that greatly improves the speed of the overall test suite. So that's one way of thinking about these tests and diving deeper into understanding what some of those techniques are going to, continually going on that journey is going to prevent your tests from rotting and also from slowing down over time. I also think, of course, continuous integration is a huge factor in this. Your test should be running all the time. I typically think every test should be run on every check-in to code, and typically I want them to run as part of every pull request. That's a great way to annoy people if the tests take a long time, which is a lovely side effect. If your tests take 3 hours to run, and that means you take 3 hours to merge any single pull request, that's probably something that can be improved. So typically we can do that in a number of different ways. We can increase the speed of the tests. Where we're not able to do that, we might think, oh, we've got a lot of UI tests, and those run 10 times longer than our other tests. Could we invest in some unit testing and some integration testing, which are orders of magnitude faster, and get rid of some of those slower tests, right? So then it becomes more about strategy and trade-off. But also it can just be that sometimes those tests do just take a long time to run in your current scenario. And then maybe you do say, okay, well, in order for a pull request to run, we're going to do this basic set of tests and make sure that they're passing. And then after something's checked in, we're going to run a longer suite of tests. Those are all the kind of trade-offs that your group can choose to make. And the last thing I'll say is that in terms of test slowing down the overall process when you have an existing code base, I tend to prefer what I call, and what a mentor once called, the Swiss cheese method. I don't know if that's a standard term or not, but the idea being that when do we write more automated tests if it's going to slow our process down, or maybe our code isn't very testable? Well, we commit to doing it when maybe there's a bug, right? And we want to write a failing test to prove that that bug exists, which means, okay, we're going to take the time now because obviously there's a problem. So we want to prove that we have the problem and we want to prove that we fixed it. So it's worth investing at that point in writing enough of those tests. Or when we add new code and new features, we're going to invest in doing that well and doing that in a test-driven manner, which naturally produces more testable code because you're writing the test first. And so by doing that, if you imagine like a piece of paper or a square, over time you're sort of making these little circles around your legacy code. The code that changes and the code that you find bugs in, that's getting covered by test. There may be a large portion of legacy code that's running just fine, and it doesn't have tests around it. And you really wish they did, but it doesn't have to be a priority at that moment because you haven't found any issues. So in terms of tests and pausing to write tests and tests slowing down the overall development process, that's sort of how I would think about it in that case. I hope I answered your question. It's sort of, there's a lot of different angles to it to consider.
Yeah, it's a good answer, and I think I kind of like got the answer. One thing I was looking for was like, is there any report that I can refer to which kind of like resembles a real world project? Or I have been trying to find it for a long time.
Sure. So there's a few. I know there are a few projects and katas out there that start with legacy code and are built for the purposes of you adding tests around that code and refactoring the code to be more testable. I think one's called the Gilded Rose kata. I'll see if I can find it and pass it along. But that's one that might be there. In terms of real world projects that offer like a legacy code refactoring experience, I had done a workshop years ago at Tech Bash, I think, where we started with some legacy stuff and we refactored. But that was more towards .NET Core from .NET. So I don't know one offhand is the question. If I find one, I will let you know. So I'm taking an action now, actually, to look for real world refactoring exercises. Typically, how we teach that, or how I teach that in some of the certification courses I've taught, is around the idea of common issues that you encounter, which in the C# world, C# being an object-oriented language, tends to go hand in hand with the studying of solid principles and some of the ways that they might better inform your tests, right? If you're doing inversion, the inversion of control, or if you're doing, dependency inversion, if you're doing the appropriate, single responsibility, you're trying to isolate things and have them, have minimal reasons to change. These are all things that will inherently improve, in most cases, testability. And so if you're thinking about what common tools and techniques to use for testing, I would suggest that some of the refactoring around those principles is a great place to start if you're not already familiar. Solid principles tend to get, I don't know, I feel like they've become a little less fashionable as of late. But when I look at legacy code bases and the kind of testability concerns that they have, I think that groups could do well to reorient themselves to those principles and think about some of the refactorings that are associated with that and how it might help isolate their code and make it a little more testable.
Got it. Thanks, Lee, for sharing that link as well.
Thank you, Lee. Yes. And so lastly, I know a couple of tools that we haven't gotten to get into yet that I will encourage you to explore as well. I'll post them just here in the chat as well. There are 3 additional tools that are fantastic to use, and maybe I'll do a tour where I do a quick lap around them on a stream or something. The first is Bogus by Bill Chavez. It's Bill Chavez, that's a great tool for generating fake data. So if you are ever using especially if you're doing data-driven tests, or tests that modify and add data to a database, I love it because it adds real-world examples of people's names, et cetera, addresses, different types of data that you might be looking for. It's a great way to make sure that you're not generating data that somehow is helpful or not, or is making your test pass when perhaps it shouldn't. So generating some of that data up front can be very useful in terms of, I need 100 people with names and addresses. It's very helpful for things like that.
It does like GPS coordinates too and stuff. It's got all kinds of stuff. I love that.
It's phenomenal. It's a really great tool. I love it for generating sample data whenever I use some. There's a lot of great uses for that tool, and really great write-up on the repo as well. The second is a tool called Verify, which I haven't used nearly as much as I want to. But this is a phenomenal tool when you're working with API responses or responses that have lots of data, and it's a snapshotting tool. So the idea is that you run your test, and then within that test, you call Verify, and it saves that gigantic JSON payload that maybe you're getting from an API in an integration test. And then what it will do the next time is it'll check to see whether those data structures are the same. So as you're running your test, maybe if something changes or you're integrating with another service elsewhere and you want to kind of know if that response has changed, Verify is a great tool for doing that kind of comparison and tests. And the last is another great tool called FS Check. And even though it's primarily, I think, we had an F# audience in mind, it's very well useful for C# as well. And the idea behind FS Check is property-based testing. And I go into that a little bit in that blog article that I posted as well. But FS Check does property-based testing, which is to say that rather than saying, given a Pepsi and given that Pepsi costs 50 cents, you could write a property test, which instead says, given the product, when the product has a price, and I provide 25 cents more than the price, then I should get the product. And what FS Check will do is it will take that statement and it will generate 100 tests for you. And it will generate tests with all different values for that product price, for example. And if something goes wrong in one of those tests or it fails, it will reduce that error message to the error message that is helpful for you, like under what value that condition works. So if you're doing something where you're doing a lot of combinatorics, or you've got a value where you've got a lot of different examples and you kind of want to cover it, or you want to cover it in a slightly random way, fscheck is a phenomenal way to sort of take one test and build 100 tests from that does combinatorial tests, or that does tests that generate certain numbers within certain ranges and always builds different tests each time. So that's a great tool for kind of keeping yourself honest if you're providing certain sample variables or doing things along those lines. So also recommend checking that out. That's another tool that I have found to be very helpful in the toolbox. Great. And thank you, Victor. Thank you, Victor. I just saw your comment. When is the next course available? And realizing that, like, honestly, I love talking about this stuff. It's been a while since I taught a course. I really am probably going to try to break this up and do some streaming on it. And so with that in mind, I'll say, I hate saying follow me or smash that like button or whatever. But if you do want to follow me on Twitter, or I am on Twitch at SJ Colleen as well. When I do stream, it'll be live there. So. Kind of really getting the hankering to do that after this, so I think we'll certainly go that route next.
It's similar to parameterized tests in XUnit, which is that's a whole other thing. But
it's similar. It is similar to that in that it will, except from the set amount of parameters, it will sort of do that random generation of all those parameters for you, which is really helpful. But you're right, and I do encourage you to check out certainly the NUnit docs, because if you find anything wrong, you can complain to me and I can fix it. But with NUnit and XUnit, the documentations are pretty phenomenal. So especially with tools like NUnit that have some additional attributes and things that you can use on tests, I encourage you to explore those libraries deeply, because you'll learn some cool things about what they're able to do out of the box as well.
Cool. Well, we probably ought to wrap this up, but thank you again so much, Sean, for coming out, and thanks for everybody for coming out, and I'll look forward to seeing you next month.
Thank you for having me, Lee. Thanks for going a little over with me, and thanks everybody for bearing with me as we went on an adventure and had no idea where it went. So thanks a lot.
Awesome.